So thank you very much. Welcome to this another session of Everyday Mathematics. Today we move forward from what we were covering yesterday. So we move to problem 6, 7, 8, and 9 and 10 of the MIT Integration B Qualifying Exam 2011. Problem 6 is indefinite integral of 1 over hyperbolic sine x squared. Problem 7, indefinite integral of secant x to the power 4 times tangent x to the power 2. Problem 8 is the indefinite integral of the square root of cosecant x minus sine x. And problem 9 is indefinite integral of cosine x to the power 6. Problem 10 is the indefinite integral of 1 over 1 plus 2x squared plus x to the power 4. So that's what we're going to be doing today. I hope you hang in and we do solve these problems together. So solving this problem number 6, the indefinite integral of 1 over hyperbolic sine squared. The first thing I personally would like to do is to understand what hyperbolic sine x is. So this is the same as e to the power x minus e to the power negative x over 2, such that the integral of hyperbolic 1 over hyperbolic sine x squared will be equal to 1 over x minus e to the power negative x over 2 squared dx, which is equals to 4 over ex minus ex squared dx. So there's one thing I personally would like to do here to make things simple. I would divide both the numerator and maybe not. So let's do this. So we have e to the power x minus 1 over ax squared dx, which is the same as 4 e to the power 2x, because this numerator here has gotten squared and has gotten pulled out into the numerator, and e to the power 2x minus 1 squared. And so since we have our integral 4e to the power 2x over e to the power 2x minus 1 squared, I could say let u be equal to e to the power 2x, such that du dx, derivative of u with respect to x, is going to be 2e to the power 2x, and that means we can substitute with du 2 to the power x dx, which means that now our integral here now becomes 2 x dx over 2x minus 1 squared, which is twice this part becomes du, and then this becomes u minus 1 squared. So we'll keep going on. So now that we have our integral as 2 du over u minus 1 squared, this is a simple integral. It's the same as negative 2 over u minus 1 plus the integration constant, right? But we know this to be e to the power 2x, so this now becomes negative 2 e to the power 2x minus 1 plus the integration constant. We could stop there, but we could also make things a little bit simpler too. e to the power 2x minus 1 plus c is also equal to negative 2 e to the power 2x minus 1 plus c2, which is the same as e to x to the power 2x minus 1 and negative 2 minus e to the power 2x plus 1 plus c2. Since we do have a negative 2 minus e to the power 2x plus 1 over e to the power 2x minus 1 plus c2, this becomes negative e to the power 2x plus 1 over e 2x minus 1 plus c2. If we multiply times e to the power negative x times e to the power negative x plus c2, what this becomes eventually since our integral is cosh or hyperbolic cosine x over hyperbolic sine x plus c2, this is the same as hyperbolic cotangent of x plus c2, and this is our answer. I mean, we could have, or negative 2 over e to the power 2x minus 1 plus c, whatever. So whatever answer works for you is fine. There's just two ways to simplify it. Okay. Problem 7 is the indefinite integral of secant to the power 4x times the square of the tangent of x. Just some few things. The derivative of tangent of x is equals to secant of x. The derivative of tangent n to the power x is the same as n tangent of n minus 1 x sec squared x. Okay, so this is something that I just want us to have in mind, so that when you integrate, anyway, let's go and try to solve it. How I would attack this, I would say, if we have sec x sec squared x times tangent squared x dx. And again, just something to focus on. This square outside the function is the same as what we're showing here. It's not the same as, for example, here, this is not the same as sec open bracket x to the power 4 close bracket. No, this is the same as sec to the power 4x. Anyway, what is important to know is sec squared x is the same as tangent squared x plus 1. Therefore, sec squared x tangent squared x is equals to sec squared x in bracket tangent squared x plus 1 close bracket times tan squared x, like that. So since our integral has become this is the same as sec squared x tan to the power 4x plus sec squared x tan squared x. And since we saw that when you have tangent to the power nx, when you differentiate that, that's the same as n tangent to the power nx sec squared x. So for example, here we can clearly see that this is the same as tan to the power 5x over 5, because this constant needs to be removed. So our integral here is 1 over 5 tangent 5x, and this is obviously tangent to the power 3's, but with in order to remove the constant of 3 here, we will put a third there plus the integration constant. So let me just delete some stuff here so that everything is clear. So this is the answer, and yeah. So problem 8, which is the integral of the square root of cosecant of x minus sine x. This is certainly interesting. So I think the first thing to do here is to simplify cosecant x as 1 over sine x minus sine x. So this is the same as 1 minus square root of 1 minus sine squared x over square root of sine x. So 1 minus sine squared x is cosine squared x, square root is cosine x over square root of sine x. And as we can see, since we have our integral as cosine x over square root of sine x dx, cosine x is the same as the derivative of sine x. Sine x, right? And so we could just, it's very easy to say let u be equal to sine x. And what that means is the derivative of sine x over square root of sine x. This part here, since u du dx is the same as d, and so du gets to be substituted for substitute with for this part here. So this part here becomes du, so this is du integral over square root of u. And this is the same as twice u to the power a half plus integration constant, and u is sine x plus c. So our answer would be twice the square root of sine x plus the integration constant, and that is the answer that was required of us. So as simple as that. Problem 9, which is the definite integral of cosine x to the power 6. How I would express this is the same as me saying since we know cosine 2x to be equal to 2 cosine x minus 1, meaning that cosine x is the same as cosine 2x plus 1 over 2. This means that our integral is the same as cosine 2x plus 1 over 2 to the power 3. Okay, which means that we have a eighth in bracket cosine 2x plus 1 to the power 3. Using Pascal's triangle, when we have to the power 0, we get the constant 1, power 1, we get 1, 1, power 2, 1, 2, 1, 3, 1, 3, 3, 1. So this means that we have 1 over 8, the integral. For the first coefficient is 1, so we just have cosine 3x plus 3 cosine x plus 3 cosine x. Since we have 1 there, there's 1 squared here hiding, and then plus 1. Okay. So we have our integral as being cosine to the power 3x plus 3 cosine squared x plus 3 cosine x plus 1. So this is a very interesting one, and this comes from cosine 3x, this being equal to cosine 2x plus x, which is cosine 2x cosine x minus sine 2x sine x, which is the same as here we have 2 cosine squared x minus 1 cosine x. Here we have 2 sine x cosine x sine x is the same as 2 cosine cube x minus cosine x minus this is 2 1 minus cosine squared x cosine x. Since cosine 3x is equals to 2 cosine cube x minus cosine x minus 2 1 minus cosine squared x cosine x is equals to 4 cosine x minus 3 cosine x. So therefore cosine cube x is equals to cosine 3x plus 3 cosine x divided by 4. cosine 3x plus 3 cosine x divided by 4 is cosine to the power 3x. So our integral was 1 over 8 bracket cosine cube x plus 3 cosine x plus 3 cosine x plus 1. We know what this is. This is 1 over 8. And we said it's cosine 3x plus 3 cosine x divided by 4 plus 3. This part here is the same as cosine 2x plus 1 over 2 plus 3 cosine x plus 1. So let's collect like terms. This and this go together, and so we have 1 over 8 a quarter cosine 3x 3/4. So let's take this first. So this is the same as 3 over 2 cosine 2x, and then 3/4 plus 3. 4 times 3 is 12, so we have 15 over 4 cosine x. Then we have 3 over 2 plus 1, that is 5 over 2. Okay, we have our integral as 1/8 cosine 3x over 4 plus 3 over 2 cosine 2x plus 15 over 4 cosine x plus 5 over 2. So we can finally get this as a quarter, and so this is 1 over 12 sine 3x. This is 3 over 4 sine 2x plus 15 over 4 sine x plus 5 over 2 x, and plus the integration constant. So that, ladies and gentlemen, is our answer. So problem 10, that's the last problem today. So 1 over 2x squared plus x to the power of 1 over 2x squared plus x to the power 4. So which we can write as 1 over 1 plus x squared, I think. I don't know. So let's see if we can use, let x be equal to tangent theta such that dx d theta is equals to sec square theta, so that we can substitute with the x for dx with sec square theta d theta. So therefore 1 over 1 plus x squared dx is equals to 1 over 1 plus tan squared sec squared theta d theta in place of this dx. So this part itself is sec squared theta, so we have 1 over sec squared theta. So this goes with one of it, so that we now eventually have the integral of 1 over sec squared theta, which implies that this is the integral of cosine squared theta, and which is the same as we saw previously, that we can express cos square theta as half of cosine 2 theta plus 1. So this becomes a quarter sine 2 theta plus theta plus the integration constant, obviously half here, integration constant. So we said our answer is a quarter sine 2 theta plus a half theta plus c, and we say let x be equal to tan theta. What that means is that if we have a triangle here and we have angle theta, since the tangent is opposite x over 1, this becomes 1 plus x squared, so that sine theta, or 2 theta, is the same as twice sine theta cosine theta, and sine theta is going to be x over square root of 1 plus x squared. Cosine is going to be 1 over the square root of 1 plus x squared theta times 2. So this is 2x over 1 plus x squared. That's sine 2 theta. And then theta is just going to be the arc tangent of x. So since our integral is sine 2 theta plus a half theta plus c, the same as 1 over 4 2x 1 plus x squared plus a half arctangent of x plus c, which is just x over 2 1 plus x squared plus a half arctangent of x c. So this is our final answer. Well, thank you so much for your attention. If you have any question, don't hesitate. We'll be glad to answer any questions you may have.